Okay, so our formula for simple interest is interest equals principal times rate times time. So from this problem, let's identify what each of these numbers is. If we have a loan of $5,500, Trey, what does the $5,500 represent? Which letter in our formula? That's the principal. So I'm just going to make a little P up above it. That's our principal. It has an annual interest rate of 6.25%. Max here?
Yeah.
There you are. You're back there. Okay, Max, what letter would that go in?
What letter is it?
Yeah, what letter? We already used up the P. Is it the I, the R, or the T?
Wait, no, what are we trying to find?
The 6.25%.
That would go to rate.
The rate. This is our rate. This is our, and it tells you right there, it's an interest rate of 6.25%. Bella, what about the 3 years? What does that go with?
The time.
That's our time. And it's asking you to find the simple interest I. Okay, so now we're going to plug it into that formula. Nathan, can you tell me what I need to write when I plug it into the formula?
555.
Okay, before we write that, let's write I equals. Keep it really nice and organized. Okay.
555.
What is it?
5,000.
There we go. 5,500. And I'm going to use parentheses to show multiplication. I could also use dots. Okay?
Times your rate. No, times time.
No, rate is next.
Okay.
And how do I write my rate?
6.25%.
But I can't just write it using a percent because I'm not going to use the percent button on my calculator. What do I have to do to that percent?
Make it that.
Decimal.
Yeah.
Convert it to a decimal. How do I do that?
Divide.
Divide by what?
Isn't that a decimal?
Okay, it is a decimal in that it's 6.25, but 6.25% has a decimal equivalent, which is not 6.25. Okay, so like 100%, its decimal equivalent is actually 1. 50%, the decimal equivalent is 0.5. Okay, so this, no, we have to move our decimal place over 2 to the left. Now, you said divide. That's what we're doing. When we move the decimal place over, we're saying it's 6.25% out of 100. 6.25% means that there's 6.25 out of 100. When we divide this by 100, we move the decimal over 2 places. So if I move it over 2 places, what do I have?
0.06.
Good, 0.06, and I still want the 2.5. Okay, finish it up.
And then multiply by 3.
Good, multiply by 3. Okay, perfectly acceptable to use your calculator to multiply all these numbers. So we have 5,500 times 0.0625 times 3, and we get 1,031.25. So our interest is $1,031.25. That is how much interest we're going to pay on that loan. That's like about 1/5 of the original amount. So you end up paying really a great deal in interest. Okay, the challenge question, how much would you save over the course of the loan if you could get an interest rate of 5.75%? Madison.
$82.50.
Good. You would save $82.50. How many of you did the challenge problem yesterday and got that as an answer? Okay, a few of you. Can you tell us, Madison, what you did first to solve this problem?
Well, I did 5,500 times 0.0575 and 3.
Okay, so you found simple interest
And then I
using the new interest rate. Okay, is everyone with me what she did there?
subtracted.
Okay, then subtracted. So when you do this, you get an interest of $948.75, which is less than the amount of interest you would pay if you were paying a rate of 6.25. She subtracted the two numbers to find the difference, because it's asking us how much you would save. So it wants to know the difference between the two interest rates. $1,031.25 minus $948.75 does come out to $82.50. So you are saving about this much per, that's only a 0.5% when we go from 6.25 to 5.75. So if we were to go down a whole percentage point, we were to do it at 5.25, we would save twice as much. Okay, any questions about how to find simple interest? Okay, let's look at an example of how we graph simple interest. Okay, our example says you have $500 in an account that earns an annual rate of 5.1%. Now, I am just going to tell you upfront that this is not a problem from any account that I know of in the real world, because I don't know of any accounts that just give you an annual rate of 5.1%. Usually you get rates like 0.25%, which means you're multiplying by 0.0025, so you don't earn much interest in most saving accounts. The only way you can earn interest rates like that would be if you were investing in like maybe a money market or something like that. Okay, at the end of each year, you withdraw the interest you have earned. That sentence is important because if you don't take out the interest that you earned, you have something called compound interest instead of simple interest. Compound interest is a wonderful thing because what happens is if you deposit money and you have an interest rate like this, your money grows so that at the end of the first year, you've earned interest. Now you have more money in the account, so the second year the interest will be based on that amount of money. So every year you're earning interest on your interest from the previous year, in addition to your original principal. So your money keeps growing, and there's a lot of growth that way. But that's beyond the scope of what we do in 7th grade. We just do simple interest, so we kind of have to say that we take out the interest earned. Graph the total interest you earn after 1, 2, 3, and 4 years. So the first thing we're going to do is just make a table. So I'm going to put time on the left because time is usually what's called our independent variable, and we talked about that a little bit when we were doing proportional relationships. Time just kind of keeps going. The amount that you earn depends on your time. So I'm going to put on my left side time. And that time is going to be in, wait, I was going to write hours. I meant to write years, time in years. I'm going to abbreviate. And then on my right side, I'm going to write how much interest I earned, and that's going to be in dollars. I should have made a bigger table because I don't have enough space to write that, so you'll have to write small. Okay, so it wants to know the interest you earn after 1, 2, 3, and 4 years. So I'm going to need to use my simple interest formula so I can find out how much interest I'm going to earn after 1 year. So let me do that here. I'm going to do interest equals, let's see. Bryant, can you fill that in for us? What would we multiply? I want to know the interest after 1 year. Well, what's my principal?
$500.
500, so I'm going to do principal times, what's my rate?
0.051.
Good, 0.051. And what's my time? 1 year. Good. Okay, doing that on the calculator, I have 500 times 0.051 times 1. I don't need to write the times 1. And I get $25.50. So after 1 year, we're earning $25.50 in interest. Now, if I didn't take that money out, my amount wouldn't be $500 anymore. The second year, it would be $525.50. But I took the interest out. It's gone. So the second year, am I going to earn the same amount of interest? Second year will be the same amount. So how much interest will I have earned total. If I earn $25.50 the first year and another $25.50 the next year, what's my interest up to? Michael?
51.
51. So at the end of the second year, I have earned $51 in interest. How much have I earned by the end of the third year? David?
76.50.
Good. $76.50. And if I put 3 into my formula for simple interest, if I did 500 times 0.051 times 3, I'm going to get that same answer. Nathan?
$102.
$102. Good. Okay, so let me hide my calculator, but not too good. I don't want to lose it. Maybe I'll put it over there. Okay, now I have to draw a graph. So along my x-axis, I'm going to put the first column in my table, which is my independent variable. So I'm going to put time here. And I'm going to put it in years. So 1, 2, 3, and 4. Now I have to decide on my scale for the y-axis. The y-axis is going to represent interest in dollars. But I can't go by ones, obviously, because I go from $25.50 all the way up to $102. What kind of scale could I use on the y-axis? I need to go up by the same amount each time. So think about what kind of scale I could use so that I use as few numbers as possible but still fit them all in. Bella?
25.
Go by 25. I like that. So we'll start with this one representing $25. This one would be 50, 75, 100, and 125. Don't just put the numbers from the right-hand side on your graph. The numbers that you use for your scale have to be evenly spaced. So you have to pick an amount and go by it. So here we're going by 25s. So my first point after 1 year, the interest rate is $25.50. So I'm going to put my dot just barely above the 25 because this is a lot of units from 25 to 50. So it's really almost touching the 25. After 2 years, I have $51. So I'm going to put my dot again kind of just above the 50. After 3 years, I have $76.50. That's still pretty close to 75. And after 4 years, I have $102. So I'm going to put a dot right there. And I'm actually not going to connect the dots because this is only earning annual interest, so I'm not getting interest in between. They're just calculating the interest at the end of the year. Some things have monthly interest, like your credit cards have monthly interest, so every month they charge you more interest, and which means that every month you owe more, and you can end up paying minimum payments on credit cards and never ever pay them off because of that. Now they've increased minimum payments so that people have to pay more and can eventually pay them off. But if you get stuck in credit card debt, you are stuck there a long time. It's hard to dig yourself out. So don't get credit cards unless you really, really have an emergency and have to someday. Okay, any questions about this? Okay, I want you to try the next one. Okay, so you're going to make a graph, and let me take a look at the challenge. Yeah, I want you to think about this. So if you get your graph made, you have extra time while other people are still working, think about what if you don't withdraw the interest each year. So you're kind of thinking about a compound interest scenario. You might want to make a new table with the new amounts and figure out how much you have. So I encourage you to try that challenge if you have time. Okay, so this table already tells us what we're going to do. We're going to put time on the left. We're going to put interest on the right. Madison, what numbers am I going to put in for time? Good. 1, 2, 3, and 4. How do I find what to put in for interest? Good. Okay, so actually if I'm using the formula, principal times rate times time, I should put a times 1 in there. Yeah. But you don't really need it because when you multiply times 1. So what did you get as your interest for the first one? $39.90. Good. $39.90. Okay, so for year 2, Myra, what interest are we up to? You didn't get that one? Volunteer for that one. Taylor?
79.
Good. 79, and how much?
And 90.
It's actually not 90 cents, it should be 80 cents. $79.80. How much in year 3, Kayla?
$113.20.
Did you say 113?
Yeah.
No, it's not 113. It's 119. Okay, and then year 4, Reese. Good. $159.60. Kayla, what am I going to put along my x-axis? Which? Okay. 1, 2, 3, and 4, and that represents the time. So x-axis is going to be time, which leaves the y-axis to be interest. What kind of scale should I use? Megan, what kind of scale did you use? On this side of your graph?
40, 80, 12, 20, 60.
Okay, so you went by 40s. Anybody go by something different? What did you do? You went by 30s? What about you?
I went by 32.
By 32? So
Yeah.
you did like 32 to 64?
Yeah, I looked at the bottom one, it said 160, I just
Mm.
did 160 divided by 5, and I have 32.
Oh, okay, so you picked, okay, that would work. I tend to like to use numbers that are more like 30, 40, 50, that are close to some 10 or 5. So I think I'm going to go, I like the 30s. I'm going to go by 30s because I think that's going to spread it out as much as possible without going over. I actually did 25s on my graph, but I think I'll go by 30s. It's not wrong if you went by 40s. That was still a good choice too. I went by 25s. I kind of ran out at the top, so I'm going to do it this way. 40s actually wouldn't run out, so it's still a really good choice. I just picked 30, so don't be insulted if I didn't pick your 40. All right, so for one, my interest is $39.90, which is almost $40. So that's going to be like, let's see, this would be 30, 40, 50. It's going to be right about here, maybe. After 2 years, we're at almost $80, so that's going to be a little closer to the 90. After 3 years, we're at about $120, close to it. Whoops. And after 4 years, we're slightly above $150, so almost to $160. So it's going to look roughly like that. Okay, any questions about how you make the graph? Okay, who did the challenge problem? Anyone? Still working on it? Okay, if you want to work on the challenge problem, did you do it? What'd you get?
Yes. I just put 950 and she did it as well.
Okay, well, yeah, but then you also have to think about each year you have more than $950 because if she didn't withdraw the interest, you have to add on that interest and then the money compounds off of that. So how about for the challenge? I'm not going to go over that right now, but if you want to do that and show me, we can talk about that. Like, well, tomorrow's going to be kind of crazy. Maybe at the end of class tomorrow we have time to talk about that. Okay? So I'm not going to spend the time on that right now, but I will be happy. Maybe I'll put the answer on Canvas. So if you want to try it, you can check your answer on Canvas. Okay, last objective. To make comparisons using simple interest. We kind of talked about this a little bit with the challenge question in the other problem that we did. You need to borrow $1,000. You can borrow it for 3 years at 8% simple interest or for 2 years at 11% simple interest. Which loan will cost more? Okay, so let's figure this out. First, we need to find simple interest for our first loan. Jake, what's our principal? And what's our rate?
Houston?
Yeah.
8%.
Okay, how do I write 8% as a decimal?
0.08.
Good. 0.08. And then what's my time?
3 years.
3 years. Okay, so when I multiply all of that, I have 1,000. This one would actually be easy to do in our head. Times 0.08 times 3 is $240. So this one, we're gonna pay $240 in simple interest. Okay, now let's do the second loan. Reese, what's the principal? 1,000. How about the rate for the second loan? Good. Times 0.11 times the time? 2. Okay, so if we do this, we have 1,000 times 0.11 times 2 gives us 220. So the interest on this loan costs $220. So which loan is going to cost less? Nathan?
The 11% one.
The 11% one. So even though this loan has a higher interest rate, because you're paying it off over a shorter time, it's going to cost you less in the long run. Now, in the real world, usually banks do this the opposite way. If you are taking out your loan for less time, they give you a better interest rate. So you really save money if you can pay it off in less time. But a lot of people can't do that because their payments are just too high.
Yeah, but
Nathan?
see, if you just look at it, you can do like 3 times 8 is 24.
That's what I said, yeah. We
8.
should have done these in our head because these were easy to do. If you multiply 0.8 times 1,000, you get 80, and 80 times 3 is 240. So those would definitely have been easy. Okay, next one is one for you to try. And then we do have an, you know what, I'm going to skip, no, I'm not. I'm going to stay at this. So you guys are going to do this as your exit ticket. So I want to come around and look at this. And then your assignment is, I'll write it down here, textbook, page 256, 5 through 19. Some of these involve graphing, some of them involve just using the formula and finding simple interest. You probably did something, yeah. Yes, good, Avery.
I figured it out in my head. It's 3 years. 3 years.
Well, how much is it going to cost?
21.
Write down the 2 amounts. Don't say it out loud. Thank you, Nathan.